October 14th, 1944. The Lorraine countryside near Aricourt, France. Hauptmann Otto Carius, veteran Panzer commander with 150 tank kills to his name, allowed himself a thin smile as his Tigerwagen's powerful optics revealed the familiar boxy silhouettes approaching through the morning mist. "More Shermans," he transmitted to his crew, his voice carrying the casual confidence of a man who had destroyed dozens of the American medium tanks. "The Amis are generous today. They send us target practice." Below them, across the rolling farmland still scarred by summer's fighting, a column of American M4 Sherman tanks moved with cautious deliberacy, their 75mm guns traversing slowly as they advanced. To German eyes trained on the elegant, deadly lines of Panthers and Tigers, these American machines appeared almost primitive. Slab-sided hulls that rose too high above their tracks, turrets that seemed bolted as an afterthought, suspensions that betrayed every bump in the terrain. What Carius didn't know, what none of the German panzer crews positioned along the ridgeline could have imagined, was that hidden among those standard Shermans were machines that would fundamentally alter the calculus of armoured warfare on the Western Front. Within 6 months, the casual confidence of German tank commanders would transform into cautious respect, then grudging fear as they encountered a Sherman variant that could fight them on nearly equal terms. The M4A3E8, which American crews would affectionately name the Easy 8, represented the culmination of 3 years of brutal lessons learned in tank combat. It wasn't revolutionary, it didn't match the Tiger's armour or the Panther's gun, but it was good enough. Produced in overwhelming numbers, crewed by increasingly skilled tankers, and supported by an industrial base that could replace losses faster than Germany could inflict them. This is the story of how American pragmatism defeated German technical superiority, how quantity and quality merged into an unstoppable combination, and how German panzer crews' laughter turned to grim silence as they discovered what happened when the Sherman finally got it right. The Sherman tank had entered combat in North Africa in 1942 as a revelation. British tank crews, exhausted from fighting in obsolete machines that broke down constantly and caught fire easily, viewed the American M4 as a miracle of modern engineering. Reliable, mechanically sound, comfortable, and produced in staggering numbers. Against German Panzer III's and early Panzer IV's, the Sherman's 75mm gun was adequate. Its armour, while not thick, was well sloped and sufficient against most threats. Its mechanical reliability was unmatched. Montgomery's victory at El Alamein in November 1942 was built on the backs of 300 newly arrived Shermans that transformed the balance of armoured power in North Africa. British tankers, veterans of disastrous encounters in Crusaders and Valentines, praised the American tank effusively. Lieutenant John Cloudsley Thompson of the 4th County of London Yeomanry wrote in his diary after receiving Shermans, "After the bloody awful tin coffins we've been fighting in, the Sherman is a Rolls Royce. It starts every morning. The gun actually hits what you aim at. The gyro stabilizer is wizard. You can hit targets while moving. Revolutionary. The Americans know how to build things properly." But by 1943, the battlefield had changed. German tanks had evolved rapidly in response to encountering Soviet T-34s and KV-1s on the Eastern Front. The shock of discovering that Russian tanks were superior to German panzers in 1941 had triggered a technological arms race that produced the war's most formidable armoured vehicles. The Panzer IV received long-barreled 75mm guns that could penetrate Sherman armour at ranges exceeding 1,000 yards. The new Panther medium tank carried a devastating 75mm high-velocity gun that could punch through a Sherman's frontal armour at 2,000 yards. The Tiger I heavy tank with its 88mm gun could destroy Shermans at ranges where American tankers couldn't even see their opponent clearly. German panzer crews quickly developed a brutal confidence when facing Shermans. Oberfeldwebel Karl Broman, a Panther commander with Panzer Lehr Division, described his first encounter with American armour in Normandy in June 1944. "We engaged a group of 5 Shermans advancing through the bocage near St. Lo. The range was 400 metres. I ordered the gunner to fire when ready. First shot, the lead Sherman exploded, turret blown completely off. The Americans didn't even know where we were. They stopped, confused. We destroyed all 5 in less than 3 minutes. It wasn't combat, it was execution. The Americans kept coming though, always more. We would destroy 5 and 10 would appear. Destroy those 10 and 20 more arrived. It was like fighting an ocean. you could win every battle and still be drowning. The Sherman's vulnerabilities were well documented and brutally exploited. Its 75mm gun, using standard M72 armor-piercing ammunition, could barely penetrate a Panther's frontal armor even at point-blank range. Against a Tiger I, frontal penetration was impossible unless hitting specific weak points like the lower hull or gun mantlet. Tests conducted at the Aberdeen Proving Grounds in Maryland demonstrated the grim mathematics. A Sherman 75mm gun could penetrate 68mm of armor at 500 yards. The Panther's glacis plate was 80mm thick, sloped at 55 degrees, giving it an effective thickness of over 140mm. The Tiger's frontal armor was 100mm thick, vertical, effectively immune to the Sherman standard ammunition at any combat range. The Sherman's height, dictated by the need to accommodate the radial engine and vertical drive shaft, made it an easier target to spot and hit. At 9 feet tall, it towered over the Panther's 8 foot 10 inch height and presented a much larger target silhouette. In the bocage country of Normandy, where engagement ranges were often under 200 yards, height mattered less than in open terrain. But in the farmland of northern France and the plains of Germany, that extra height meant being spotted first, and being spotted first usually meant dying first. Its relatively thin armour, 51mm at the front sloped at 56 degrees, could be penetrated by nearly every German anti-tank weapon. The Panther's 75mm gun could punch through Sherman frontal armour at ranges exceeding 3,000 yards. The Tiger's 88mm gun could do so at over 3,500 yards. Even the infantry's Panzerfaust, a single-shot disposable anti-tank weapon, could destroy a Sherman at 60 yards. Most infamously, the early Sherman's gasoline engine and ammunition storage arrangement made it prone to catastrophic fires when penetrated. The ammunition was stored in sponsons along the sides of the hull, unprotected except by the relatively thin side armour. A penetrating hit often ignited the ammunition, producing a catastrophic explosion that killed the entire crew instantly or trapped them in an inferno. German tank crews called them Ronsons, after the American cigarette lighter whose advertising slogan promised "Lights first time, every time." American tankers developed their own gallows humour, calling their tanks Tommy Cookers or Zippos. The dark joke among Sherman crews was that if you survived one knockdown, you'd probably survive the war, because the statistical odds of surviving two were essentially zero. The casualty statistics told a grim story. In the first weeks of the Normandy campaign, Sherman losses exceeded 50% in some units. The 2nd Armoured Division lost 133 tanks in the first 30 days of combat. The 3rd Armoured Division would lose over 250 Shermans before the war's end, with many tanks being destroyed and replaced multiple times. One Sherman, nicknamed In Again, Out Again, was knocked out and repaired 7 times before being finally destroyed beyond recovery. Crews knew that statistically, a Sherman would be knocked out after an average of only 5 days of frontline service. The psychological impact was devastating. Tankers climbed into machines they knew were outmatched, praying that American numerical superiority and air support would see them through. Some crews painted extra armour plates on their tanks using scavenged metal. Others sandbagged their hulls, adding weight that strained suspensions and transmissions. Some welded on spare track links, creating improvised armour that provided minimal protection but enormous psychological comfort. Field modifications became so common that General Eisenhower's headquarters issued directives limiting them, fearing that the added weight would cause mechanical failures. Lieutenant Belton Cooper, an ordnance officer with the 3rd Armoured Division, wrote after the war about the brutal reality of Sherman combat. The Panther could knock out a Sherman at ranges where we couldn't even damage it. The Tiger was even worse. We developed tactics of trying to get multiple Shermans into position to hit a German heavy tank from the sides or rear. The rule of thumb was that it took 5 Shermans to destroy one Panther. 4 would be knocked out in the process. Cooper's job was recovering damaged tanks and identifying casualties. His memoir, Death Traps, described in horrific detail the aftermath of armoured combat. Shermans with turrets blown 30 feet from the hull by ammunition explosions. Tanks burned so hot that aluminum components melted and crew remains were reduced to ash. The smell of burned flesh that permeated every knocked-out tank. After major engagements, Cooper's recovery teams would work through the night, pulling destroyed Shermans from the battlefield, recovering the dead, salvaging usable parts. The work was gruesome and psychologically devastating. Cooper estimated that during the European campaign, the 3rd Armoured Division suffered over 500% casualties among tank crews. Men were wounded or killed and replaced multiple times. Some replacement crews lasted less than a day before being knocked out. The constant turnover meant that veteran crews became precious resources, their experience valued more than the tanks themselves. The German confidence in their technical superiority was not unfounded. The Panther SFG, entering production in 1944, represented perhaps the finest balance of firepower, protection, and mobility achieved by any tank during the war. Its 75mm KWK 42L70 gun could penetrate 140mm of armour at 1,000 yards. Its glacis armour, 80mm thick, sloped at 55 degrees, was effectively immune to the Sherman's 75mm gun at combat ranges. Its weight of 45 tons was distributed across wide tracks, giving it reasonable mobility even in soft terrain. The Panther could reach 34 miles per hour on roads, faster than the Sherman's 30 miles per hour, despite weighing 10 tons more. Hauptmann Wilhelm Bartelborth, commanding a company of Panthers with the 2nd Panzer Division, experienced the intoxicating feeling of invulnerability that German tankers felt. In September 1944, near Nancy, we engaged an American armoured column, 15 or 20 tanks, all Shermans. They saw us and immediately tried to manoeuvre for flank shots. Our company was hull down on a ridge. We simply waited for them to present targets. It was like a shooting gallery. One by one they burned. Some tried to close range. Suicide. Their shells bounced off our glacis like pebbles. A few hits rang against our turret, no penetrations. When the survivors retreated, we counted 11 burning Shermans. We had taken no losses, no casualties, not even serious damage. This happened not once but repeatedly. The Americans were brave, even reckless, but bravery cannot defeat physics. The Panther's optical systems were superior to anything the Allies fielded. The gunner's TZF-12A telescopic sight provided 2.5x magnification with exceptional clarity. The commander's cupola featured 7 periscopes providing all-around vision. In good conditions, German gunners could identify and engage targets at ranges where Allied tankers saw only indistinct shapes. This optical advantage, combined with superior firepower and armour, created a devastating synergy that made the Panther perhaps the most feared tank on the Western Front. But German panzer crews were also discovering uncomfortable truths about their supposedly superior machines. The Panther, while formidable in combat, was a maintenance nightmare. Its complex final drive units failed regularly, often after less than 1,000 miles. The problem stemmed from the Panther's rushed development. Originally designed as a 30-ton medium tank, it had grown to 45 tons without corresponding strengthening of the drivetrain. The final drives, essentially the gears that connected the engine's power to the tracks, were rated for a 30-ton vehicle. Under the stress of the actual 45-ton weight, they failed catastrophically and frequently. Its engine, the Maybach HL 230 P30, was underpowered for the tank's weight and prone to fires. Producing 700 horsepower, it gave the Panther adequate performance, but the engine ran hot and stressed. The engine compartment was cramped, making maintenance difficult. Worse, the fuel and oil lines ran along the top of the engine, and combat damage often caused leaks that ignited on the hot engine surfaces. Panthers burned from engine fires almost as often as from enemy action. Its transmission required careful handling that inexperienced drivers, increasingly common as German losses mounted, often couldn't provide. The Maybach transmission was a precision instrument, a marvel of German engineering when operated correctly. But it required smooth, careful gear changes. Rushed shifts or improper clutch work could strip gears or burn out clutch plates. By late 1944, German driver training had been reduced from 6 months to 6 weeks. New drivers simply didn't have the experience to handle the complex transmission properly, leading to mechanical failures that removed tanks from action as effectively as enemy fire. A joke circulated among German maintenance crews. How do you recover a broken-down Panther? You wait for it to be destroyed by enemy fire, then the Americans will tow it away for you. The joke reflected a bitter truth. German recovery vehicles and spare parts were increasingly scarce. A Panther that threw a track or broke a final drive often had to be abandoned because there were no means to repair or recover it. The Americans, by contrast, had dedicated recovery vehicles, abundant spare parts, and maintenance units that could rebuild a tank in the field. The Tiger Boy, while fearsome, was even worse. Weighing 54 tons, it required enormous amounts of fuel, averaging less than 1 mile per gallon. On roads, a Tiger consumed about 300 litres of fuel per 100 kilometres. Off-road, consumption could double. With Germany's fuel situation increasingly desperate by late 1944, Tigers often sat immobilised simply because there was no fuel to move them. Its complex overlapping road wheel design, while providing excellent ride quality, was prone to jamming with mud and ice. The Tiger used a Schachtelaufwerk suspension system with overlapping road wheels. This design distributed the massive weight evenly and provided a smooth ride. But mud or snow packed between the overlapping wheels could freeze solid overnight. In Russian winter conditions, crews sometimes spent hours chipping ice from between wheels before the tank could move. On the Western Front in the winter of 1944-1945, the same problem occurred. Tigers that were mobile in the evening could be frozen solid by morning. The road wheels themselves were rubber-tired, and by late 1944, Germany's rubber shortage meant that replacement wheels were often steel, which wore quickly and provided poor traction. Most critically, German industry could not produce these advanced tanks in sufficient numbers. Total Panther production reached approximately 6,000 units across all variants. Tiger production totaled only 1,347 tanks. By contrast, American factories produced over 49,000 Shermans of all types. The Sherman that German crews mocked was being produced at a rate of over 2,000 per month at peak production. The Chrysler tank arsenal in Detroit could produce 500 Shermans monthly. The Fisher Body plant in Grand Blanc, Michigan, produced 11,000 Shermans during the war. The Ford Motor Company plant in Edgewater, New Jersey, the Pacific Car and Foundry in Renton, Washington, the Federal Machine and Welder Company in Warren, Ohio, the Baldwin Locomotive Works in Philadelphia, and other facilities combined to create an industrial juggernaut that Germany simply could not match. Even with superior individual performance, German tanks were being swamped by sheer numbers. The mathematics were brutal and inescapable. If it took 5 Shermans to destroy 1 Panther, but America could produce 10 Shermans for every Panther Germany built, the equation favoured America. Lose 5 Shermans destroying a Panther, build 10 more, do it again. Germany couldn't sustain those losses. Oberleutnant Hans von Luck, commanding a reconnaissance battalion that included Panthers, wrote in his diary in October 1944, "We destroyed 8 American tanks today, a victory by any measure, but intelligence reports the Americans have shipped over 4,000 tanks to France since June. When will we run out of ammunition before they run out of tanks? This is not a question of courage or skill anymore. It is mathematics, and the equation does not favour us." Into this desperate equation, the Americans introduced a solution that German intelligence initially dismissed as insignificant. Reports began reaching German headquarters in late 1944 of modified Shermans appearing in small numbers, wider tracks, different suspension, slightly different silhouette. The assessments were casual. Minor improvements to an obsolete design, no significant threat increase. An intelligence summary from Army Group B headquarters, dated November 3, 1944, noted, "Prisoner interrogations indicate the enemy is fielding improved Sherman variants with enhanced suspension systems and possibly improved armament. Current assessment suggests these modifications represent incremental improvements rather than fundamental capability enhancement. No change to current tactical doctrine recommended. These assessments were catastrophically wrong. The M4A3E8 Sherman represented the culmination of every lesson learned from 3 years of armoured combat." The designation itself told the story. M4 was the basic tank design. A3 specified the Ford GAA V8 gasoline engine, the best power plant fitted to any Sherman. E8 indicated the horizontal volute spring suspension system, a complete redesign of the running gear that transformed the tank's mobility. But the designation didn't capture the dozens of other improvements that collectively made the EZ8 a fundamentally different machine from the Shermans that had landed in Normandy. The development of the EZ8 had begun not in a laboratory, but on the battlefields of North Africa, Sicily and Italy. After-action reports from tank commanders consistently highlighted the same problems: insufficient gun penetration against improved German armour, poor mobility in soft terrain, high casualties from ammunition fires, inadequate crew protection. The Ordnance Department responded with typical American pragmatism. If the basic Sherman design was sound but outclassed, improve it incrementally until it was competitive again. The 76mm gun had been available since mid-1944, but early installations were problematic. The gun was longer and heavier than the 75mm, requiring modifications to the turret and gun mount. The additional weight made the already nose-heavy Sherman even more unbalanced. Some crews actually refused the 76mm gun, preferring the 75mm because its high explosive ammunition was more effective against infantry and fortifications. In Normandy's close-range fighting, where targets were more often machine gun nests and anti-tank guns rather than enemy tanks, high explosive effectiveness mattered more than armour penetration. But the gun was only part of the solution. The suspension system that gave the Easy 8 its designation proved equally transformative. Standard Shermans used a vertical volute spring suspension system, VVSS, that had been cutting-edge design in 1940 but was showing its age by 1944. The VVSS used narrow tracks, 16.5 inches wide, and small road wheels. The vertical springs compressed under load, but the system had limited travel, meaning that the tank bounced and pitched over rough terrain. Ground pressure, the weight distributed over the tracks, contact area, was relatively high at 13.9 pounds per square inch. This meant that Shermans bogged down in soft terrain where wider-track German tanks could operate. The most visible change was the suspension. The new horizontal volute spring suspension system, HVSS, used wider tracks, 23 inches compared to 16.5, spreading the tank's weight more effectively. Ground pressure dropped to 10.5 pounds per square inch, better than the Panther's 12.8 and comparable to the Tiger's 10.3. This seemingly minor change had profound effects. In mud, snow, or soft soil, Easy 8s could go where standard Shermans bogged down. Larger road wheels and horizontal springs provided dramatically improved ride quality and terrain handling. The springs were mounted horizontally rather than vertically, allowing for greater suspension travel. This meant the tank could absorb larger obstacles without the crew feeling every bump. The road wheels were larger, 26 inches in diameter compared to 20 inches on VVSS Shermans, which allowed them to roll over obstacles more easily. The difference was immediately apparent to anyone who had driven both types. Corporal Jim Flowers, a Sherman driver with the 4th Armoured Division, who transitioned to the Easy 8 in December 1944, described the change. It was like going from a buckboard wagon to a Cadillac. The old Sherman bounced and pitched over rough ground. Hit a pothole at speed and you'd bang your head on the hatch. The Easy 8 just floated over obstacles. You could maintain speed cross-country that would have shaken the old Sherman apart. The wider tracks meant you could go places that would bog down a standard Sherman. In snow or mud, the difference was even more dramatic. I drove through snow that would have stopped a regular Sherman cold. The wider tracks just walked over it. The improved mobility had immediate tactical implications. Sherman crews had learned that survival often depended on getting to cover quickly, or manoeuvring for flank shots against superior German armour. The Easy 8 could do both faster and more reliably than standard Shermans. In the fluid, fast-moving battles of early 1945, where American armoured divisions were advancing dozens of miles per day, the improved mobility meant Easy 8 units could keep up the pace while maintaining combat effectiveness. But the mobility improvements, while significant, were not what made German panzer crews suddenly cautious. The real transformation came from the gun. The Easy 8 was armed with the 76mm M1A2 gun, a high-velocity weapon that had been available since mid-1944 but fitted initially only to limited numbers of Shermans. The 76mm gun was actually 76.2mm, 3 inches, essentially the American version of the excellent British 17-pounder gun. It fired a 15.4-pound armour-piercing projectile at 2,600 feet per second, compared to the 75mm gun's 14.6-pound projectile at 2,030 feet per second. That difference in velocity combined with a heavier, more aerodynamic projectile dramatically improved penetration. Earlier 76mm Shermans retained the problematic VVSS suspension and other limitations. The Easy 8 combined the better gun with improved mobility and numerous other upgrades, creating a package that was greater than the sum of its parts. The 76mm gun-firing M93 armor-piercing, capped ballistic cap ammunition could penetrate 130mm of armor at 1,000 yards. This meant it could reliably penetrate a Panther's side armor at combat ranges. The Panther's side armor was 45mm thick, well within the 76mm gun's capability at typical engagement ranges. Against a Tiger's side armor 80mm thick, it was equally effective at ranges under 800 yards. Even frontal shots at closer ranges under 500 yards could penetrate vulnerable areas like lower hull plates or turret rings. The Panther's lower glacis plate was only 60mm thick at a less severe angle, vulnerable to the 76mm gun at close range. The turret ring, the joint where the turret met the hull, was a structural weak point on all German tanks. A hit there could jam the turret or penetrate into the crew compartment. More importantly, the 76mm gun gave Sherman crews the confidence to fight. They were no longer helpless against German heavy armor. The battle was still not equal. A Panther's gun remained superior, its frontal armor still largely immune, but it was no longer hopeless. American tank commanders developed new tactics that leveraged the 76mm gun's capabilities. Instead of requiring elaborate flanking maneuvers to get side shots, Easy-8s could engage from frontal aspects at closer ranges, targeting weak points with reasonable probability of penetration. Sergeant Lafayette Poole, one of the most successful American tank aces with 12 confirmed German tank kills before being wounded in September 1944, received an Easy-8 after returning to duty in December. His assessment was blunt. This is what we should have had from the start. The gun can kill anything the Germans have if you know where to hit them. The suspension lets you get into position to take those shots, and the whole tank just feels solid, like it was built right instead of built fast. Poole's experience illustrated the importance of crew quality. An experienced commander who understood German tank vulnerabilities, where to aim, when to shoot, could make the Easy-8 devastatingly effective. The 76mm gun gave him the tool he needed to exploit his knowledge. Poole would add several more kills to his tally before war's end, all with his Easy-8. The Easy-8 incorporated dozens of other improvements that collectively enhanced combat effectiveness. The turret featured all-around vision cupolas, giving the commander vastly improved situational awareness. The commander's cupola had 6 vision blocks arranged in a circle, allowing the commander to scan 360 degrees without moving. This was crucial because the commander's primary job was not firing the gun, but maintaining awareness of the tactical situation, identifying threats, and directing the crew. The gunner received an improved telescopic sight and a new gun stabilizer that actually worked, allowing reasonably accurate fire while moving at speeds up to 15 miles per hour. The stabilizer, an improved version of the system used in 75mm Shermans, kept the gun generally on target as the tank moved. It wasn't accurate enough for precision shooting, but it allowed the gunner to keep the sight on target and fire immediately when the tank stopped, saving precious seconds in combat. Wet ammunition storage, with rounds surrounded by water glycerin jackets, dramatically reduced the fire hazard that had made Sherman's death traps. The system worked by surrounding ammunition storage bins with a liquid mixture. If the armor was penetrated and the ammunition hit, the liquid would flood the storage area, absorbing heat and preventing ignition. Statistics showed that wet storage reduced the probability of ammunition fire after penetration from 60 to 80% to less than 15%. Crews noticed the difference immediately. Tanks that were penetrated but didn't burn gave crews a chance to escape. The psychological impact of knowing your tank probably wouldn't turn into a crematorium if it was profound. Men fought more effectively when they weren't terrified of being burned alive. Additional armor improvements included a thicker, better-angled glacis plate, and the elimination of several shot traps where shells could deflect into thin armor. The glacis armor was increased from 51mm to 63mm on some late-production Easy-8s, and the angle was optimized to increase effective thickness. Shot traps, design features where a shell could hit, deflect, and strike a thinner piece of armor were eliminated through careful redesign of turret and hull junctions. Improved welding techniques created stronger joints less prone to failure under impact. Early Sherman production had used riveted construction in some areas, but by 1944, all welded hulls were standard. The welds themselves were improved through better technique and material selection, creating joints that were actually stronger than the base armor plate. The power traverse for the turret was upgraded, allowing the gunner to track moving targets more effectively. The hydraulic system that rotated the turret was given more powerful pumps, allowing the turret to rotate 360 degrees in 15 seconds, faster than most German tanks. This was crucial in fluid combat situations where threats could appear from any direction. Even small details mattered. Improved engine access panels made maintenance faster. The engine deck was redesigned with larger, easier-to-remove panels that allowed mechanics to access critical components without removing the entire power pack. Better. Crew heaters made winter operations more bearable. A gasoline-fired heater kept the crew compartment warm in sub-zero temperatures, maintaining crew effectiveness during winter fighting. Upgraded radio equipment improved communication. The SCR-5228 radio set provided reliable voice communication up to 20 miles, allowing better coordination between tanks and with higher headquarters. Individually minor, collectively these changes transformed crew effectiveness and survival. An Easy-8 crew was more comfortable, better informed, more confident, and more likely to survive than a crew in a standard Sherman. These factors combined to make the Easy-8 significantly more effective than its specifications alone would suggest. The Ford GA engine, producing 500 horsepower from its 18-litre V8 configuration, was the most reliable power plant fitted to any Sherman variant. Unlike the earlier radial engines, which were aviation engines adapted for tank use, the GAA was designed from the start as a tank engine. It was relatively compact, allowing for lower hull height. It was mechanically simpler than the various diesel or multi-bank engines used in other Sherman variants, making field maintenance easier. Most importantly, it was powerful enough to push the Easy-8's 33-ton weight at speeds exceeding 30 miles per hour on roads and 20 miles per hour cross-country. The GA engine was also remarkably reliable. Mean time between failures exceeded 1,000 miles, exceptional for a WFOT tank engine. German engines, pushed to their limits to provide adequate power for increasingly heavy tanks, rarely achieved such reliability. The Maybach engines in Panthers and Tigers required major maintenance every few hundred miles. The GA could run for months with only routine oil changes and minor adjustments. This reliability translated directly into operational readiness. Easy-8 units routinely reported 85 to 90% of tanks operational at any given time. German Panzer units, by contrast, often had fewer than half their tanks operational due to mechanical problems. In a war of attrition, operational readiness was as important as combat capability. German intelligence began receiving concerning reports by January 1945. Interrogated American prisoners mentioned new Shermans with wider tracks and bigger guns. German tank crews reported increasingly effective American gunnery. Several Panthers had been penetrated from frontal aspects at ranges previously considered safe. A penetrating hit through the lower glacis plate, destruction of the final drive by a shot that penetrated the front hull, turret jams from hits to the turret ring. These reports were fragmentary and unclear, but a pattern was emerging that troubled German commanders. An intelligence assessment from the 5th Panzer Army dated January 12, 1945 noted, "Recent engagements suggest the enemy has fielded improved Sherman variants in unknown numbers. Tank commanders report enemy capabilities inconsistent with known Sherman performance. Specifically, enemy tanks demonstrating improved cross-country mobility in snow and soft terrain, improved gunnery accuracy, and armor penetration capabilities against Panther side and lower frontal armor at medium ranges. Recommend detailed tactical study and updated engagement doctrine." But by January 1945, the German army was in crisis. The Battle of the Bulge had failed, consuming Germany's last strategic reserve of armor and fuel. The Russian winter offensive was crushing Army Group Center. Resources for detailed tactical studies were non-existent. German panzer commanders would have to learn about the Easy-8 the hard way, through combat. The first major engagement where Easy-8s demonstrated their capabilities occurred near Bastogne in January 1945 during the final German counterattacks following the Battle of the Bulge. The 4th Armoured Division, which had spearheaded the relief of Bastogne on December 26th, included several companies recently equipped with Easy-8s. By early January, these units were positioned defensively, having outrun their supply lines during the rapid advance to Bastogne. On January 9th, a company of Easy-8s from the 37th Tank Battalion encountered elements of the 9th Panzer Division, including 4 Panthers near the village of Warden. The Germans were attempting to cut the Bastogne corridor, isolating the defenders once again. The Panthers were moving in column along a snow-covered road, confident that the Americans lacked the capability to threaten them at range. Staff Sergeant John Danforth, commanding one of the Easy Eights, described the engagement. We were moving up a snow-covered road when the lead tank reported Panthers hull down about 200 yards ahead. In an old Sherman with a 75, we would have tried to work around them, get close, hit them from the side. Could take an hour or more, and they might spot us and reposition. We didn't have to do that anymore. I ordered the gunner to engage the rightmost Panther, range 200 yards, target moving slowly left to right. He fired, solid hit on the turret, didn't penetrate the frontal turret armour, but it got their attention. They started backing up to get into better hull-down positions. We put 2 more rounds into him as he moved. One hit the lower hull as he backed over the crest of the ridge, went through, smoke, then fire. The other Panthers opened fire, rounds hitting around us, snow and frozen dirt flying everywhere. One round bounced off our glacis, hit so hard I thought we'd been penetrated. Loud as hell inside, ears ringing but no penetration. The shot had hit at an angle and deflected up and away. We got into a little depression, hull-down position, and kept firing. Over the next 10 minutes we knocked out 2 more Panthers. The loader was working like a machine, ramming rounds into the breach as fast as the gunner could aim and fire. The gunner, Private Morrison, was brilliant. He put round after round, exactly where they needed to go. Lower hull shots when they exposed their undersides going over terrain. Side shots when they turned to reposition. One turret ring shot that jammed the turret and forced the crew to bail out. The 4th Panther escaped, pulled back behind a village where we couldn't get a clear shot. We took a hit to the turret that jammed the traverse temporarily, but we fixed it with sledgehammers, just bent metal that needed to be hammered back into shape. No casualties, no serious damage. This was different. We'd fought Panthers before in our old tanks. Usually it meant casualties and destroyed tanks. You'd lose 2 or 3 Shermans taking out 1 Panther. This time, we won clean. 4 Easy 8s against 4 Panthers, we destroyed 3 and drove off the 4th without losing anyone. German after-action reports from the 9th Panzer Division reflected growing concern. Enemy Sherman-type tanks, possibly new variant, demonstrated improved gunnery effectiveness. 3 Panthers lost to frontal engagement at medium range. Previously, such losses only occurred in close-range ambush situations. Tank crews report enemy shells penetrating armour that should have been immune at engagement ranges. Morale impact significant. Crews no longer confident of invulnerability against standard American tanks request immediate intelligence assessment of enemy capability improvements. Hauptmann Werner Stumpf, who commanded the Panther company that fought at Woerden, was more direct in his personal diary. The Americans have improved their damned Shermans. The new ones are faster, more stable, and their guns can hurt us. We lost 3 tanks to frontal fire at ranges where we should have been safe. Müller's tank took a hit through the lower glacis that killed the driver and radio operator instantly. The tank burned. Schroeder's tank was hit in the turret ring, the turret jammed and they had to abandon. Werner's tank took multiple hits. One penetrated the side as he tried to reposition. He got his crew out, but the tank was a total loss. This is bad, very bad. Our advantage is shrinking. We can no longer assume safety at medium range. The Americans are shooting better, their guns are more powerful, and they're not afraid anymore. That last part might be the most dangerous. When they were afraid, they were cautious. Now they engage aggressively, confident in their machines. The war is changing, and not in our favour. The tactical implications rippled through German panzer formations. For 2 years, German tank commanders had approached combat with American armour confident in their technical superiority. That confidence enabled aggressive tactics, accepting engagements at ranges and in situations where more cautious commanders might have withdrawn. Now that calculus was changing, a Sherman that could kill your Panther from the front at 1,000 yards was a very different threat than one that had to manoeuvre for close-range flank shots. German tank. Commanders began issuing new tactical guidance. Avoid engagement at medium range unless holding overwhelming advantage. Prioritize destroying improved Sherman variants first, identifiable by wider tracks. Maintain greater engagement distances where Panther gun superiority remains decisive. Use terrain aggressively to prevent American tanks from closing range. These defensive tactics, while sensible given the changing threat, represented a fundamental shift in German armoured doctrine. For the first time on the Western Front, German tank commanders were being told to be cautious when engaging American armour. The psychological impact on crews already exhausted by years of combat was significant. The Easy-8's appearance coincided with other developments that collectively overwhelmed German armoured forces. American tank crews were becoming increasingly skilled. The replacements arriving in late 1944 and early 1945 benefited from training that incorporated hard lessons from Normandy and the subsequent campaigns. They arrived knowing how to fight German armour, where to aim, how to use terrain, when to advance and when to withdraw. The training program for American tankers had been completely overhauled after the Normandy experience. New tank commanders went through specific training on German tank vulnerabilities. They studied recognition guides that showed the weak points of Panthers, Tigers and Panzerfools. They practiced on mock-ups that replicated German tank silhouettes. They watched gun camera footage from actual combat, seeing what worked and what didn't. They fired thousands of practice rounds on ranges, learning the capabilities and limitations of their weapons. By late 1944, an American tank crew arriving in Europe had typically spent 6 months in training. The commander had 400 hours of instruction. The gunner had fired 500 practice rounds. The driver had 200 hours behind the controls. Compare this to German crews in the same period. Compressed training schedules meant new German tank crews often had less than 8 weeks of instruction. Commanders had perhaps 50 hours of tactical training. Gunners fired maybe 50 practice rounds, and sometimes fewer due to ammunition shortages. Drivers learned on obsolete tanks because there were no Panthers or Tigers available for training. The American artillery support that had always been formidable became even more responsive and effective. Forward observers with tank units could call fire missions that would have dozens of guns firing within 3 minutes. Time-on-target missions could bring hundreds of guns to bear on German armour concentrations within 5 minutes, with all shells arriving simultaneously for maximum shock effect. Proximity-fused shells, appearing in late 1944, were devastating against exposed infantry and soft-skinned vehicles supporting German tanks. These shells used a radio proximity fuse that detonated the shell at optimal height above the ground, creating a deadly airburst. That was far more effective than standard contact-fused shells. German infantry learned to stay in deep cover whenever American artillery was active. Tanks without infantry support were vulnerable to American tank infantry teams that could approach under artillery cover. American air superiority was total. P-47 Thunderbolts and P-51 Mustangs prowled behind German lines, destroying fuel trucks, ammunition carriers, and recovery vehicles. The impact on German armoured operations was devastating. A Panzer division required approximately 200 tons of supplies daily: fuel, ammunition, food, spare parts. All of this had to be trucked forward from railheads that were themselves under constant air attack. Trains couldn't run during daylight. Trucks moved only at night with headlights off, crawling along roads at walking pace. Tanks that broke down, increasingly common for German armour, couldn't be recovered and repaired because the recovery vehicles couldn't reach them without being attacked from the air. They had to be abandoned. Panthers that ran out of fuel became pillboxes, then target practice. A broken track or failed final drive, repairs that would take hours under peacetime conditions, became death sentences for tanks because recovery was impossible under Allied air supremacy. Oberst Rudolf von Waldenfels, commanding a Panzer regiment with the 11th Panzer Division, wrote in February 1945, "We are being strangled. Not defeated in battle, but strangled. Our tanks are excellent. Our remaining crews are experienced. But we have no fuel. We have no spare parts. We have no recovery capability. A tank that throws a track must be abandoned because we cannot recover it. The jabots, the fighter bombers, own the daylight. Nothing moves. We hide during the day like rats, move only at night. The Americans advance in daylight with complete freedom. They have air cover, artillery support, and now tanks that can actually fight ours. We are finished." Most critically, American production ensured that losses could be replaced immediately, while German losses were permanent. The logistical pipeline from American factories to European battlefields was functioning with industrial efficiency. A Sherman company that lost 6 tanks in combat would report the losses to battalion headquarters. Battalion would report to division. Division would report to corps. Corps would requisition replacements from the theatre depot. Within 48 hours, 6 factory-fresh tanks would arrive, driven by delivery crews from the depot. The company would receive them, The regular crews would perform acceptance checks, load ammunition, fuel up, and the tanks would be in combat the next day. The entire process from loss to replacement took 3 days. A Panther company that lost 3 tanks might never see replacements. German tank production in early 1945 was collapsing. Allied bombing had destroyed key factories and severed transportation networks. Raw material shortages meant that tanks completed were often missing critical components. Some Panthers rolled off production lines without radios, without proper optics, sometimes without complete armor plate. The few tanks that were produced often couldn't reach frontline units because the transportation network was destroyed, trains were bombed, trucks had no fuel, tank transporters were destroyed by air attack. Panthers produced in February 1945 were still sitting at the factory when the war ended, unable to reach the front. By January 1945, some German panzer divisions reported fewer than 20 operational tanks against authorized strengths of over 100. The 9th Panzer Division, which had started the Battle of the Bulge with 50 tanks, reported 8 operational Panthers and 3 Panzer IVs by February. The 2nd Panzer Division reported 12 operational tanks. The 116th Panzer Division reported 15. These were not divisions. They were reinforced companies pretending to be divisions. Into this environment, the Easy-8 appeared not as a war-winning superweapon, but as the final piece of an overwhelming puzzle. German commanders realized they now faced opponents who had numerical superiority, air superiority, artillery superiority, logistics superiority, and increasingly, tanks that could fight them on nearly equal terms. Oberstleutnant Rudolf Baer, commanding a panzer regiment with the 11th Panzer Division, wrote in a February 1945 report to division headquarters. The improved Sherman variant is appearing in increasing numbers. Our crews report approximately 1 in 4 American tanks now features the wider tracks and more effective gun. This proportion is rising weekly. By March, intelligence estimates the majority of American tanks will be this improved type. The tactical situation is becoming untenable. We can no longer assume safe engagement ranges against American armor. Panthers must treat these improved Shermans with the same caution previously reserved for Soviet T-34 SOR-85s or the rare British Fireflies. The problem is the crews are experienced enough to exploit this. They use terrain well, concentrate fire, and coordinate with their excellent artillery. Yesterday, my 2nd Battalion engaged an American armoured column. Initial reports suggested 20 to 25 Shermans, mixture of standard and improved types. We achieved good initial positions, destroyed 4 tanks with opening shots, all standard 75mm types. Then the Americans deployed smoke, manoeuvred, and called artillery. Under artillery fire, we lost tactical cohesion. 3 Panthers were destroyed by tank fire. The crews reported the enemy tanks firing from hull-down positions at ranges under 800 metres. 2 more Panthers were destroyed by what crews report as aircraft attack, though I suspect it was actually artillery. 1 Panther was abandoned due to mechanical failure, the final drive, while under fire, and could not be recovered. We destroyed perhaps 8 American tanks total, difficult to confirm in the confusion. This was, once, a favourable exchange. We would accept losing 6 tanks to kill 8. Now, we know the Americans will have those 8 tanks replaced by tomorrow. Our 6 lost Panthers are gone forever. This same action repeated daily means the mathematics of extinction. We are trading irreplaceable assets for replaceable ones. The engagement patterns changed throughout February and March 1945, as German commanders adapted to the new reality. Aggressive tactics that had worked for years became suicidal. Panzer commanders became cautious, avoiding engagement unless holding overwhelming advantage. This caution, while sensible tactically, was strategically disastrous. German armour was supposed to counterattack, to disrupt American offensives, to restore broken defensive lines. Cautious tanks sitting in defensive positions might survive longer, but couldn't accomplish their mission. The doctrinal mission of German panzer divisions was mobile warfare, rapid counterattacks to destroy enemy penetrations, exploitation of breakthrough opportunities, aggressive offensive action. By February 1945, German armour was reduced to static defence, ambush tactics, and immediate withdrawal after contact. This represented the complete failure of German armoured doctrine. American tankers noticed the change. Sergeant William Castile, commanding an Easy-8 with the 2nd Armoured Division, described operations in March 1945. The Germans weren't pushing anymore. They'd shoot from defensive positions, try to stop us, but they wouldn't come out and fight. Sometimes we'd take fire from a tree line or a village. We'd deploy, manoeuvre to flank, call up artillery. By the time we got into position, they'd be gone, pulled back to the next defensive line. When we did catch them, they'd fight for a bit, knock out a tank or two, then withdraw. The desperation was obvious. They were trying to preserve their remaining armour, but that just let us keep advancing. I remember thinking the Germans had always been aggressive, even reckless. Back in Normandy, they'd counterattack constantly. You'd take a position and within hours German tanks would be hitting you trying to take it back. Now they fought like they were afraid. Afraid of losing tanks they couldn't replace. Afraid of losing crews they couldn't replace. Just afraid. It was sad in a way. These were brave men fighting for a lost cause, knowing every day that the war was ending and they were on the losing side. The Easy 8 demonstrated particular effectiveness in urban combat, a common occurrence as Allied forces pushed into Germany. The improved stabilisation allowed accurate fire while moving through rubble-filled streets. The gunner could keep the sight on target while the tank moved at 10 miles per hour over rough ground, something impossible in standard Shermans. This meant Easy 8s could fire effectively while moving, a crucial advantage in urban fighting where stopping made you a target for Panzerfausts, the faster turret. Traverse helped deal with threats appearing suddenly from side streets or buildings. In urban combat, threats could appear from any direction with no warning. A Panzerfaust team in a building, an anti-tank gun in an alley, an enemy tank around a corner. The ability to rotate the turret quickly and engage was often the difference between killing the enemy and being killed. The 76mm gun could penetrate the concrete and brick fortifications that German defenders used to protect anti-tank guns and Panzerfausts. A high-explosive shell from the 76mm gun could blast through a brick wall and detonate inside a building, clearing out defenders. Armour-piercing rounds could punch through concrete pillboxes that would resist smaller weapons. During the fighting for Cologne in early March 1945, Easy 8s from the 3rd Armoured Division proved instrumental in reducing German strongpoints. The city was heavily defended, with German troops determined to hold the Rhine River crossing. Every building was a potential fortress, every street corner a potential ambush site. The fighting was brutal, building to building, room to room. The famous footage of a Pershing tank destroying a Panther in the streets of Cologne overshadowed the less dramatic but more significant contribution of dozens of Easy 8s, systematically clearing defensive positions. The Pershing engagement was dramatic, captured on film and featured in newsreels, but there was only one Pershing in Cologne. There were 36 Easy 8s, grinding through the city street by street. Lieutenant Clarence Smoyer, who commanded the Pershing in that famous duel, noted in post-war interviews that Easy 8s were doing the bulk of the fighting. The Pershing got the glory because someone filmed it. That fight lasted maybe 30 seconds. One shot from us, one from the Panther that missed, then our second shot killed them. It was over. But there were 30 or 40 Easy 8s in Cologne doing the same job, just without cameras rolling. They fought for days, clearing the city building by building. Those tanks and crews won that battle. The improved Shermans were everywhere by then. They were the standard, not the exception. Every tank company had them. Every engagement featured them. They'd become the workhorse of the American armoured force. German tank production collapsed in the final months of the war. Allied bombing had destroyed key factories and severed transportation networks. The Daimler-Benz plant in Berlin, which produced Panther components, was bombed repeatedly. The MAN factory in Nuremberg, another major Panther producer, was reduced to rubble. The Henschel plant in Kassel, which produced Tigers, was destroyed. Even factories that remained operational couldn't get raw materials. Steel production had collapsed. Aluminum was unavailable. Copper for electrical components was exhausted. Rubber for road wheels didn't exist. Raw material shortages meant that tanks completed in March 1945 often lacked critical components. Some Panthers rolled off production lines without radios, without proper optics, sometimes without complete armour plate. The quality control that had characterised German production early in the war was completely absent by 1945. Tanks were assembled from whatever components were available, regardless of whether they met specifications. A Panther completed in March 1945 might have road wheels from 3 different manufacturers, none of which properly fit. The transmission might be a rebuilt unit from a destroyed tank, worn out and unreliable. The gun might lack its rangefinder. The radio might be an obsolete model from 1942. These weren't proper tanks. They were assemblages of parts, barely functional, unlikely to survive even a few days of combat. In contrast, American tank production remained at peak efficiency. The factories were untouched by war, operating with skilled workers, abundant raw materials, and refined production processes. By March 1945, the majority of Shermans reaching frontline units were Easy-8 variants. The older models were still produced for specialized roles and for equipping units in the Pacific, but in Europe the Easy-8 was becoming the standard medium tank. Production had ramped up through late 1944 and early 1945. The Chrysler tank arsenal was producing 400 Easy-8s monthly. Fisher Body in Grenblenk was producing 350 monthly. Other plants contributed smaller numbers. Total production exceeded 1,000 Easy-8s per month by March 1945, more than Germany's total tank production of all types. The quality was exceptional. Every tank was built to exacting specifications. Every component was tested. Every system was verified before the tank was accepted. When an Easy-8 rolled off the production line, it was ready for combat. No missing parts, no substitutions, no compromises. It was a complete, fully functional weapon system that would operate reliably for thousands of miles. The kill ratios, while still favouring German tanks on a one-to-one basis early in engagements, had shifted dramatically by the war's end. In the final 2 months of the war, Easy-8s achieved approximately a 1-to-1 exchange ratio with Panthers in tank versus tank combat, a dramatic improvement from the 5-to-1 ratio of earlier Shermans. Against Panzer IVs and other medium German armour, Easy-8s dominated completely. The Panzer IV, which had been Germany's workhorse tank throughout the war, was completely outclassed. Its 75mm gun couldn't penetrate Easy-8 frontal armour at combat ranges. The Easy-8's 76mm gun could destroy a Panzer IV at any range. Engagements between Easy-8s and Panzer IVs were massacres. The improved mobility was particularly valuable during the rapid advances of March and April 1945. American armoured divisions raced across Germany, covering distances that would have been impossible earlier in the war. Patton's Third Army advanced over 100 miles in some weeks. The First Army raced to the Elbe River. The Seventh Army drove into southern Germany and Austria. Easy-8s proved mechanically reliable during sustained high-tempo operations, suffering fewer breakdowns than standard Shermans and far fewer than German tanks. The operational readiness rates told the story. Units equipped with Easy-8s typically reported 85 to 90% of tanks operationally ready at any given time. They could move all day, fight when necessary, and be ready to move again the next morning. German panzer divisions, equipped primarily with Panthers and Panzer IIIs, reported operational readiness rates between 30 and 50% in the final months. Half their tanks were broken down at any given time. Superior individual tank performance meant nothing if the tanks couldn't move. One revealing metric was operational readiness rates tracked over time. The 4th Armoured Division, equipped primarily with Easy-8s by March 1945, reported 87% operational readiness on March 1st. By April 1st, after a month of intensive combat and rapid advances covering hundreds of miles, they still reported 82% operational readiness. The 11th Panzer Division, one of Germany's elite formations, reported 45% operational readiness on March 1st. By April 1st, they reported 22%. They weren't losing tanks to enemy action, they were losing them to mechanical failure and inability to repair or recover them. The psychological dimension of the Easy-8's impact was significant but difficult to quantify. German tankers interviewed after the war consistently mentioned the improved Shermans as a turning point in their perception of American armour. The tank that they had mocked in 1943 had become a capable opponent by 1945. The transformation wasn't just technical, it was psychological. Lieutenant Fritz Langanke, a Panther commander captured in April 1945, expressed a common sentiment. When the Americans first came with their tall, gasoline-burning Shermans, we were confident. We had superior tanks, superior training, superior tactics. We would win. Individual engagements proved this. We would destroy 5 of theirs for every one of ours lost, but we couldn't sustain it. By 1945, we knew we had lost. Their new Shermans were good enough. Not better than our tanks, but good enough. Combined with their numbers, their air power, their artillery, good enough was more than enough. I was not afraid of their tanks individually. A Panther was still superior to a Sherman in direct combat. But knowing that every Sherman I destroyed would be replaced tomorrow while my losses were permanent, that was terrifying. The improved Shermans just made an impossible situation worse. They could actually hurt us now. We had to treat them seriously, and we didn't have the resources to fight seriously anymore. The M4A3E8 was not a superweapon. It did not match the Panther's gun or the Tiger's armour. In ideal conditions, a well-positioned Panther crew would still defeat an EZ-8 more often than not. Head-to-head, on a firing range, the Panther would win. But wars are not fought in ideal conditions or on firing ranges. They are fought in mud and snow, with tired crews, with mechanical problems, with fuel shortages, with limited ammunition, with constant air attack, with artillery fire disrupting every movement. In real combat conditions, the EZ-8's combination of firepower, mobility, reliability and availability made it the more effective weapon. The tank that could fight today was more valuable than the tank that might be superior but was broken down or out of fuel. The tank that could be replaced tomorrow was more valuable than the irreplaceable super tank. The production numbers tell part of the story. Over 4,000 EZ-8s were produced before war's end, with production accelerating in early 1945. Had the war continued, production was scheduled to exceed 1,500 per month by summer 1945. Germany's total tank production in the first 4 months of 1945 was approximately 750 vehicles of all types, most of which never reached frontline units. The disparity was overwhelming and insurmountable. The training advantage had also shifted decisively. American replacement crews arriving in 1945 averaged over 300 hours of training in tanks. They knew their equipment, they knew tactics, they had practiced gunnery extensively. They arrived in Europe ready to fight. German replacement crews, when available at all, sometimes had less than 50 hours of training. They arrived barely competent to drive and shoot, learning on the job if they survived long enough to learn anything. In March 1945, the 7th Panzer Division reported receiving 12 replacement Panthers. Of the 48 crew members, only 8 had more than 3 months of tank training. 4 drivers had fewer than 20 hours behind the controls of a Panther. The Panther was a complex machine that required skilled handling. Inexperienced drivers broke transmissions. Inexperienced gunners couldn't hit targets. Inexperienced commanders made tactical mistakes that got their crews killed. The division commander noted bitterly that the Americans were training their tank crews better than Germany was training its officers. The EZ-8's finest moment came during the final weeks of the war as American forces raced to the Elbe River and drove deep into southern Germany. Armoured spearheads covered hundreds of miles in days, a pace that would have been unthinkable earlier in the war. The combination of speed, reliability and fighting power proved decisive. Entire German armies were encircled and destroyed, not because they were defeated in battle, but because they couldn't move fast enough to escape. Near Leipzig on April 18, 1945, a company of EZ-8s from the 5th Armoured Division encountered one of the last organised German armoured formations, a depleted Panther battalion with perhaps 15 operational tanks attempting to cover the withdrawal of Wehrmacht infantry. The Germans were trying to establish a defensive line that would allow the infantry to escape encirclement. The Panthers were well positioned, hull down on a ridge overlooking the main road. In 1943, this would have been a formidable defensive position. In 1945, it was barely an inconvenience. Captain James Leach, commanding the EZ-8 Company, engaged from advantageous positions. His after-action report was matter-of-fact. Enemy armour identified at 400 yards hull-down positions on ridgeline, counted approximately 15 vehicles, identified as Panther medium tanks, deployed company in line, directed gunners to engage on command, opened fire simultaneously with 8 tanks at 1,355 hours, 4 enemy vehicles hit immediately, 3 destroyed and burning, 1 disabled and crew bailing out. Remaining enemy armour withdrew under smoke cover, displacing to secondary positions approximately 3,000 yards to rear, pursued and maintained contact, engaged withdrawing enemy armour at ranges from 800 to 1,200 yards over next 20 minutes, destroyed 3 more confirmed, possibly 2 additional. Enemy armour broke contact and withdrew in disorder. No friendly losses, no damage requiring more than field repair, minor hit to Lieutenant Harrison's tank, no penetration, superficial damage to turret, total operation time, 23 minutes from initial contact to enemy withdrawal. The German battalion commander, Hauptmann Josef Ritter, was captured the following day when his remaining tanks ran out of fuel. He was interrogated about the engagement. His response reflected the complete reversal of the situation from 1943. What could we do? They had good positions. We were exposed on the ridgeline, but there was nowhere else to position. Their guns could hurt us. The improved Shermans, we knew them by now. They were coordinated, well-trained. Every tank fired simultaneously. Overwhelming fire. 4 tanks destroyed in the opening seconds. We tried to reposition, but they pursued. Their tanks were faster than ours over rough ground. We were low on ammunition, perhaps 20 rounds per tank. Low on fuel, maybe 50 kilometers of range. Half my crews were replacements with minimal training. My gunners couldn't hit moving targets consistently. Their gunners put rounds exactly where they aimed. We did what we could, then withdrew. It was logical. Why die for nothing? The war was over. We knew it. Fighting accomplished nothing except getting more men killed. By late April 1945, German resistance had largely collapsed. The panzer arm that had terrorized Europe for 5 years was reduced to scattered remnants, immobilized by fuel shortages, destroyed by air attack, or simply abandoned by crews who saw no point in continued sacrifice. The Easy 8 had not single-handedly defeated German armour, but it had arrived at the critical moment when American forces needed a tank that could fight effectively in sustained high-intensity operations against an increasingly desperate opponent. The psychological impact of the Easy 8 on German crews was perhaps its most significant contribution. For 2 years, German tankers had relied on technical superiority to offset numerical inferiority. When that technical superiority eroded, when they faced opponents who could fight them on nearly equal terms, the psychological advantage evaporated. German crews who had fought confidently in 1943 fought cautiously in 1945, and cautious tank crews rarely win battles. The Easy 8 continued serving after the war, proving its worth again in Korea, where its reliability and firepower remained effective against both enemy armour and fortifications. In Korea, Easy 8s faced Soviet-supplied T-34-85s, tanks comparable in many ways to the Panthers they had fought in Europe. The engagements demonstrated that the Easy 8 was competitive against any medium tank of its era, when crewed by well-trained tankers. The last Easy 8s were retired from US service in the 1950s as new designs like the M46 Patton entered service, but many served with Allied nations into the 1980s, a testament to the soundness of the design. Israeli Easy 8s fought in 1967 and 1973. Pakistani Easy 8s served until the 1980s. The design that was rushed into production in 1944 proved durable enough to serve for nearly 50 years in various armies worldwide. At the German Tank Museum in Munster, a restored Panther sits near a preserved Sherman Easy 8, silent veterans of battles 70 years past. The placard between them notes the specifications, the combat records, the technical details. The Panther's superior gun, thicker armour, and more powerful engine are dutifully recorded. The Easy 8's wider tracks, improved suspension, and reliable power plant are noted. But the human story is told by a small display of wartime documents, including a February 1945 intelligence assessment from a German Panzer regiment. The improved American Sherman tank is now the standard type, encountered in 80% of engagements. Our initial assessment of this variant as only a minor improvement was incorrect. The combination of improved mobility, effective armament, superior crew training, and the enemy's overwhelming numerical and logistical superiority has created a tactical situation that cannot be sustained. Crews report increasing reluctance to engage when American armour is known to include these improved types. This is not cowardice, but recognition of reality. We can no longer rely on technical superiority to offset numerical disadvantage. Our tanks remain superior in individual combat, but individual combat is no longer the determining factor. The enemy fights with combined arms, artillery, air power, and overwhelming numbers. Their improved tanks are the final piece of this combination. Recommendation: avoid engagement unless absolutely necessary for mission accomplishment. Preserve remaining armour strength for critical defensive operations. Accept that offensive armoured operations are no longer feasible. Next to this document is a letter written by Hauptmann Otto Carius in April 1945, shortly before his capture. Carius, who had started the war mocking American tanks, had survived to see those same tanks overwhelm his forces. I remember in 1943 we laughed at the American tanks. Tall, awkward, easy to destroy. We called them Ronsons and Tommy Cookers. Every engagement confirmed our superiority. We destroyed them by the dozen. We were proud, confident, certain of victory because our equipment was superior. We are not laughing anymore. The Americans learned, they improved, they adapted. Their new Shermans are good enough, and they have thousands. We have experience and courage and technically superior machines. But you cannot fight mathematics. You cannot fight industrial capacity. You cannot fight an enemy who learns from mistakes and has the resources to implement solutions. Eventually the numbers win. 1,000 good enough tanks defeat 100 superior tanks. That is the lesson. We were tactically superior and strategically defeated. The improved Shermans are a symbol of why we lost. Not because they were better tanks than Panthers, they weren't, but because they were good enough, and there were enough of them, and they kept coming no matter how many we destroyed. The M4A3E8 Sherman Easy 8 entered combat as a solution to an urgent problem: how to give American tank crews a fighting chance against superior German armour. It succeeded not by matching German tanks in individual performance, but by being good enough in all the ways that mattered. Good enough armour to survive occasional hits, good enough gun to kill German tanks when used properly, good enough mobility to manoeuvre effectively, good enough reliability to keep fighting day after day, and produced in good enough numbers to ensure that American armour would never be outnumbered. The transformation from the early Sherman that German crews mocked to the Easy 8 that they respected was not primarily technical. Yes, the Easy 8 was better, but the real change was systemic. Better training for American crews, better tactics developed through hard experience, better combined arms coordination, better logistics ensuring tanks were fueled, armed and maintained, better industrial support ensuring losses were immediately replaced. The Easy 8 was the beneficiary of all these improvements, the platform that allowed American advantages in training, tactics and logistics to be fully expressed. German tank crews had mocked the Sherman in 1943, confident in their technical superiority. They destroyed Shermans by the hundred, victories that felt decisive at the time but were strategically meaningless. By 1945, that mockery had transformed into grim respect for an opponent that had learned, adapted, and ultimately prevailed not through individual excellence, but through systematic superiority in every aspect of industrial warfare. The Easy 8 was the Sherman that finally got it right, arriving at the moment when the accumulation of American advantages in every area except individual tank performance reached critical mass. The war ended with American armour triumphant, German panzer forces destroyed, and the Easy 8 proving that in modern warfare, good enough in overwhelming numbers beats perfect in insufficient quantities every single time. The laughter that German crews had directed at the tall, awkward Shermans in 1943 had died long before the Easy 8 appeared. By 1945, there was no laughter left, only exhausted acceptance of inevitable defeat. The Easy 8 didn't create that defeat. It simply made it final, undeniable, and complete. The tank that German crews had mocked had evolved into the tank that buried them under an avalanche of steel, and by the time they recognized the transformation, it was far too late to matter.